Assalamualaikum warahmatullahi wabarakatuh. Today we were going to do an overhaul master cylinder. Next we're going to the first step. First of all, eject the master cylinder. Next, take out the reservoir. We loosen the screw on the side of the reservoir. And when you have removed the screw, just pull the reservoir from the piston. Next step is remove every seal that is there by just pulling it by using our hand, because it can be moved easily. Next, we want to remove the piston. Then open the screw for the stopper screw piston that is there. Then the pin by using a tool. As we can see, the piston will indeed be stuck. However, you only need to tap it to remove the piston from the body, because there is already oil inside that helps make it easier. See the first pistons in front, it's called as a rear side brake control, and the second one is to control the front side brake.
For the inspection, the O-ring was instead and showed no sign of crack or deformation. For the primary and secondary piston, it was rusty and oily. For inner surface of master cylinder show a visible rusty. For the diaphragm, flexible and undamaged. For brake booster, appeared to be in good condition with no visible crack or corrosion.
We measure the inside base of the master cylinder body, and then we get that this is 16.10. After that, we measure the flat of the master cylinder body. We get that is a 24.52, and we get 24.52 minus 16.10. We get that the result is 8.42 mm. After that, we adjust the push rod length until the result get the push rod end is 9.7 mm. So it is between the standard value, so it's acceptable. Using same method, take the 25.80 minus 60.10. So we'll get the 9.7 mm of the push rod end after adjust. For master cylinder part name, first is reservoir assembly, second is reservoir cap, third is fuel level sensor, fourth is filter, fifth seal, and sixth is retainer, 7 piston stop board, 8 brake fuel reservoir, 9 is seal for fuel pack, and 10 is primary piston stop pin, and 11 is dust cover, 12 is secondary piston assembly, third is primary piston assembly, and the last is the master cylinder body.
Refitting the master cylinder. First of all, put the piston into the master cylinder body. Before you putting back the O-ring, make sure you put the primary piston stop pin at its original place. Then tighten the pin with the screwdriver. Only after that you putting back the O-ring at its original place. Then take the brake fluid reservoir and put it together with the master cylinder. Make sure you tighten the screw between the master cylinder and the brake fluid reservoir. And last one, assemble it back to the brake booster.
So for the discussion during this laboratory section, the master cylinder push rod length was measured and adjusted to evaluate its effect on brake operation. So the initial push rod length was 8.42 mm, which is below the standard specification. Is 9.65 between 9.90 mm. So this short length would result in excessive brake pedal free play and slower hydraulic pressure build up. So the push rod was then adjusted to the 9.70 mm, bringing it will hit the correct range to ensure the proper piston movement and the brake response. So, however, during assembly, it was found that the reservoir seal, rubber seal between the reservoir and the master cylinder body was already broken. This condition could have been caused by, again, for the rubber material improper handling during the private assembly or over tightening of the reservoir. A damaged reservoir seal can cause the brake fluid lacking and the air enter into the hydraulic system, so leading to a drop in the braking efficiency and a soft bladder feel.
Name the type of brake oil used for our car and whether a different type can be used. For our vehicle, the type of brake fluid that we commonly use is .4. This is type of brake oil is glycol-based and designed to work effectively under high temperature and pressure. It helps maintain smooth and responsive braking performance, especially during long drive or heavy braking situations. Now, can we use a different type of brake oil? Technically, some type like .3 and .4 can be mixed because they both glycol-based. However, it's not recommended since each type has different boiling point and chemical properties. On the other hand, .5 is silicone-based and it should never be mixed with .3 or .4 fluid. Doing so can cause serious problems like brake failure or damage to the internal rubber seals in the master cylinder. So in conclusion, we should always follow the manufacturer's recommendation for the correct brake fluid type. This ensures the braking system performs safely and efficiently.
So for the question 3, the answer is the master cylinder is connected to the brake hydraulic tube that send brake fluid to each wheel. Usually, there are two circuits, one for a front brakes and one for a rear brake. The tubes from the master cylinder will go through the brake propelling valve or ABS unit and then continue to the brake caliper and wheel cylinder. This allows the pressure from the master cylinder to reach all wheels when the brake pedal is pressed.
For the discussion, question number 4, one of the functions of the diaphragm is separate the vacuum and atmosphere chamber. Inside the brake booster, one side of the diaphragm is under vacuum and the other side get atmospheric pressure when you press the brake. The second one is to create the axis force. When you press the brake pedal, atmospheric pressure enter one side. The pressure difference push the diaphragm forward. This movement multiplies the braking force applied by the driver. The third one is to transfer the transfer force to the master cylinder. The diaphragm is connected to a push rod. When it moves, it helps push the master cylinder piston, making braking easier. The last one is to maintain the airtight sealing. It prevents the vacuum leaking, ensuring the consistent brake boost. Conclusion for this experiment is we learn how to remove, inspect and refitting a master cylinder correctly. We check the condition of each part such as piston, O-ring, diaphragm and the inner surface. We also adjusted the push rod and ensure the brake system work properly after rebleeding. Overall, the lab helped us to understand how the master cylinder function and why the proper inspection is important for the safety of the braking system. Thank you.